Welcome to the Engineering Update. I'm Casey Panetta, editor of ECN. In this week's episode, the first aerial cameras with micro 4/3 sensors, a 3D printed house for Mars, and a responsive sports bra that ventilates when you sweat. With rumors floating around about GoPro entering the camera drone market, it's no surprise DJI unveiled its two latest cameras for its own flagship drone, the Inspire 1. The cameras, named ZenMuse X5 and ZenMuse X5R, weigh in at only 340 grams and are the first aerial cameras to hit the market featuring micro 4/3 sensors. The cameras will offer drone pilots 13 stops of dynamic range for flexibility in different lighting conditions, 16 megapixel resolution, and the ability to shoot 24 and 30 frames per second 4K video, as well as standard still pictures, of course. The cameras will also support 4 different wide-angle lenses from DJI, Panasonic, and Olympus. As an added bonus, the X5R has the ability to support onboard microSD and 512GB mounted SSD storage. It also captures footage in RAW format, which can be tweaked and edited in DJI's Cinelite software. Pilots also have access to a D-Log mode, which provides a wider range of color correct options during the post-production process. Built-in cameras aren't exactly a new thing for drones, however, previous cameras didn't quite deliver professional results. The integration of bigger sensors will give professionals a far higher dynamic range, as well as save them money and make their lives much easier. A standalone X5 will cost you about $2,200 and will begin shipping at the end of the month, but if you want the X5R, you'll have to wait for it to hit shelves later this year. Even though we're years and probably decades away from getting to Mars, let alone establishing a colony on the red planet, it's still fun to think about what that settlement might look like. Fabulous, a French firm inspired by a NASA competition for 3D printed habitats, went ahead and showcased what our future homes could look like, and they are, well, fabulous. It's a 3-story dome-style dwelling that's partially underground. The top story, which is more like a loft, will be used to grow food and vegetation on 32-square-foot platform. The main floor will house a bathroom and workspace in 312 square feet, and the lower floor, measuring about 430 square feet, will serve as a sleeping quarters. A spiral staircase connects all the floors. The entire living area is accessible by one long hallway from the outside, which connects to the home via an airlock. 3D printed has been lauded as a great solution for space because it would allow people to construct exactly the type of dwelling they need without having to carry a cumbersome object from Earth. It will also help keep the weight of the spaceship down. Fabulous took this a step further and created a home that can be constructed from materials found on Mars. The company's plan involves extracting iron from the planet and using permafrost to insulate the housing with water to reduce solar radiation. The iron will be extracted via robotic arms on the main mast of the home. This may not be what homes on Mars actually look like. In fact, it's pretty much certain it won't be. But Fabulous's final goal is to have the home constructed in Mars' Gale crater.
Intel has teamed up with architectural sportswear designer Chromat to produce responsive garments, a sports bra and a dress, which actually change shape in response to the wearer's body temperature, adrenaline, or stress levels. The garments, dubbed the Chromat Aero Sports Bra and the Chromat Adrenaline Dress, are powered by the Intel Curie module and were unveiled during the Spring-Summer 2016 runway show at Made Fashion Week. The button-sized module packs a low-power 32-bit microcontroller, 6-axis motion sensor with accelerometer and gyroscope, integrated digital signal processing sensor hub, pattern matching technology, Bluetooth Low Energy, and 384 kilobytes of flash memory and 80 kilobytes of RAM. I need more. Designed for wearable electronics, it's power efficient and is supported by a software platform developed specifically for the unit. The dress is made of neoprene stretched over 3D print panels with a carbon fiber framework attached to the back. The carbon fiber framework, activated by a shape memory alloy, will expand in an hourglass shape when it detects an adrenaline rush, which in this case is indicated by an increase in sweating and breathing rate. The sports bra consists of Lycra, mesh, neoprene, and 3D printed frames. Like the dress, it also integrates shape memory alloy, but uses it to open vents in the bra to provide a cooling airflow when it detects changes in the wearer's perspiration, breathing, or body temperature. It will also shut off the vents when things cool down a bit. The module isn't available yet, but the Chromat was one of the select companies that had the chance to sample the device. And although the concept sounds pretty neat, I'm not so sure I'd want my dress expanding on me the moment I start to sweat. That's all for this week's Engineering Update. Be sure to check in on Twitter and Facebook and catch past episodes at ecnmag.com. For the ECN channel, I'm Janine Mooney, and this has been your Engineering Update. Again, we said Engineering Update.